Welcome to this morning's debate on automatic inspection and testing technologies. How will it affect test engineers? SBI, AOI and X-ray have been developing over the last few years and becoming more sophisticated, more intelligent, gathering more data. And that's going to continue with automatic programming and various other aspects coming into the test process. How is that going to affect engineers? We're going to discuss this with a panel of experts here today. To my extreme right, we have Satoshi Otaki from SAKI Corporation. Welcome. To his left, we have Joel Scutchfield from Co-Young. To his left, we have Richard Osborne from OMRON. And of course, to my extreme right, we have Brian.
From MIRTEC.
Brian D'Amico from MIRTEC. Sorry, I'm only kidding. I'm only kidding. So, gentlemen, welcome. I'm glad you joined us this morning. Let's kick off with our first question. A number of you are introducing automatic programming. Is that going to become mandatory in test systems going forward? Let's start with you on the end, Satoshi.
So we just we have been over 25 years experience from 2D AOIs, and then about 10 years ago, so we started the business like a 3D AOI development. Because of the reason behind we found that like a 2D AOI business is a kind of shrinking in the futures. But and then now is a lot of customers requested us to automate like a programming, and then to reduce like indirect costs, because as you see that a lot of customers allocated more technicians or programmer to program, but most of the customers are spending several hours to complete programs. So we just launched like a self-programming functions. We call that the SAKI self-programming, so SSP. So we just launched this software, and then I believe that this software will be standard in this industry in the very soon.
Joel, there's a cost saving and a time saving basically by introducing automatic programming.
Of course, absolutely. We all hear the same thing as we're talking with customers, prospective customers. Programming time is always one of the first things they ask about, right? Mm-hmm. And a sidebar to that is also the net result of program creation using the human element, right? So I think we're looking to do a couple of things here. We certainly want to speed up the programming time or reduce programming time in general, but we also want to, while doing that, making the program more accurate, right? Less need for tuning, more robust, and I think that's really the key driver here. And the customers, ourselves as competitors in the market, will continue to push the envelope, and that one button click programming that everybody's after is not too far out there. I really think we're very close.
Richard, I mean, it's almost going to become mandatory because smart factory and reduced downtime is making everything faster. It's making much more machine uptime. So that means that you've got to have your programming done, your lines ready to go much quicker. What's the OMRON approach to this?
Well, that's a very good comment that you made about machine uptime. And first of all, thank you for having me. Mm-hmm. OMRON appreciates it. OMRON, at its core, is an automation company. And per this discussion, we actually have today available AI controllers that are in the field and being able to be used and to monitor or control production lines throughout the line from beginning to end. So it is true machine learning, mm-hmm. and the absolute core of it is to minimize and eliminate unknown downtime. Right. It is predictive in letting you know when something is going to occur that can affect things in our production of a printed circuit board.
Right, so you're saying AI systems. I mean, OMRON covers more than just test. You've got AGV robots and different things in the factory space. So are you talking about some sort of holistic system that's controlling that space, or are you talking specifically about your machines?
OMRON offers it's the NX and NY controller series that are true artificial intelligence driven systems. Our systems operate on the edge, which is different than other people that have these systems that want to send the data up to the cloud, have the processing done up there, and then bring it back down. We do it right at the machine level, so it's much faster, it's much more predictive, and ultimately yields better results.
Okay. Brian, MIRTEC recently introduced automatic programming. How has that affected, or how does it work, and how has it affected the programming of the OMRON AOI systems?
Well, we don't program OMRON AOI systems, but that's okay.
Okay.
You said OMRON.
Oh,
We don't. As a matter of fact, we try not to program OMRON. No.
I'm needing more coffee, I think.
Get me some too. I need scotch.
Freudian slip. Yeah.
Now, to answer your question, you asked if it was going to be standard. Yes, automatic programming is going to be standard for all those good reasons that we've discussed.
Yeah.
The bottom line is straightforward. If you're spending time programming the machine, you're not making any money. And here in the States, we're talking about low to medium volume. That's where you make the money from. That's what 90% of our customers are doing, right? And then they take that to maybe higher volume, but still you have that initial either NPI or the low to medium volume where you get a lot of money for the boards, right? You make more money that way. But you have to program quickly. If you don't, you're not going to be able to get the machine running. So we introduced what's called IntelliPro. And IntelliPro software, it's automatic program generation. It has an AI engine. Now this combined with 3D, and that's really why we're able to do automatic programming, is because we're talking about 3D systems.
Yep.
With a 3D machine, if you take the Gerber information and you take the Centroid information, you marry the two together, the machine can actually physically go to each location and determine what component is there. Because with the 3D, we can measure length, width, height of the device. We can match that up with a package, a pre-programmed package from a library, and it can, once again, program automatically. It'll step through the Centroid, program all of the part numbers, add those part numbers to the library. Bottom line is you could produce a program in 15 minutes that may have taken an hour, 2 hours, 3 hours. Right. So absolutely it will become mandatory.
Yeah, great. Okay. Now, most of you guys are also starting to work more in the semiconductor space and back-end packaging. That brings in a whole bunch of challenges as well with miniaturization and reflective devices. How do you cope with that? Let's go back to the end of the line there and start with SAKI.
About a kind of like a spectral surface, like a mirror surface, for the semiconductors, like a double CSPs. It's since we are using like a more technologies on the AOI device, so it's kind of challenging for us. But instead of that, we have like a 2D ring lighting, and also we have like a side angle camera to back up to inspecting for this kind of difficulty. And on the top of that, we have like a 3D X-ray solutions to measure that this kind of wafer level CSP on the mirror surface device to inspect and measure or without any failures and false code.
Right. So using a combination of 2D and 3D to try and detect these reflective devices.
Yes, that's great.
Yeah. What is your take on this, Joel?
Yeah, we've actually come out with a new tool specifically for the semicon industry. It's called the Meister, and we're able to offer that for both paste inspection and device inspection, so SPI and AOI. And it's a little bit different approach. Obviously, we're working with much finer resolution, 5 micron, sub 5 micron, for detection of coplanarity on shiny surfaces, cracks, and those types of things. So again, we went certainly using the same core technology that we've always utilized, but with a bit of a twist, right? And showing very good results. We have that system here at the show, and we've gotten very good feedback on that. The SPI tool has been already, or SPI version, I should say, has been very well accepted in the market. The AOI version is is basically in release as we speak.
So what's the twist that deals with the reflective devices?
I don't know that I can get into that.
I see.
Too much.
All right, we're getting into dangerous
know what I mean.
territory here, are we? Richard, OMRON, you've been in the back-end semiconductor space as well for a while.
Yeah, we sure have. And as far as reflectivity and the miniaturization, it's no challenge for us. If there's visual things that can differentiate, we have the tools to pick those up. Certainly we use 3D. We still use some 2D in the AOI space. And then, of course, on the X-ray, we have a very unique CT 3D capability.
Right.
And so we provide full coverage on this with no issues.
Mm-hmm.
And we continue to work towards satisfying the continued miniaturization as well. We've got some new systems that'll be coming out.
And what sort of tolerances do you go down to on your miniaturization?
Well, we're down in the not sub-micron, but certainly in the micron level.
Mm-hmm. Okay. Brian, it's a growing space for you, the semiconductor back-end packaging, and of course reflective devices. How do you deal with that?
Yeah, reflective devices is a challenge for anybody using Moire. The bottom line is if you've got wafer level devices, these are shiny die, they're like mirrors on the board. Standard Moire, you're really not going to be able to pick it up. What we've done is we've modified our projection engine, and we're using what's called blue DLP Moire. And we find that we get more information back, like 30% more information back. And we did that specifically for dealing with the fact that we have wafer level devices, as well as the other shiny surfaces like solder, etc., right? Mm-hmm. Those shiny surfaces present a problem. You get noise. The only way to resolve that noise is to filter it out. If you filter out the noise and you filter out too much noise, you start losing data that you require to determine if you have a good solder joint or you have a good CSP, coplanarity on the CSP. So it's really critical that you start, one, with the proper projection engine. The blue DLP just made the big difference. And we see a lot of customers that now have die and SMT that coexist on the board. And that's not going to get any less. It's going to get more and more in the future. The nice part about MIRTEC, I always say, we do have the most advanced technology out there. I'm sorry, but we do. It's my opinion. But what it really comes down to is, we'll do a different debate.
There we go.
The reason why is because we're kind of looking at what the customer's going to need in the future. We can see that here in the States and Europe. We can see that starting to filter in, and we're preparing in advance for that. So that's what we've done, is introduce the
So
blue
using
DLP.
a blue filter essentially is what you're using?
No.
No?
No, it's not a blue filter, although there is a blue filter aspect of it. It's actually blue projection technology, blue LED projection technology.
Okay.
The wavelengths of the blue light is different than wavelengths of white light. So we're able to collect 30% more information, which gives us that added accuracy.
Okay, excellent. Okay. Satoshi, let's turn our attention now to metrology. It's pretty much key to the digitizing all the results coming off of the line. How important do you think it is going forward? I mean, AOI has come through basically being an image-based comparative technology, but it really needs to be, going forward, it needs to be metrology-driven. Would you agree?
Yes,
how important is metrology, measurement, basically, being able to measure the devices and their positions on the board and that sort of thing, so that you can digitize that information and send it back into the systems?
yes. It's well, yes. Everybody talking about now like a smart factory, and then on the industry 4.0, and then of course we have like a SPI and a AOI and a 2D AOI also, and a 3D AXI machines, and then we are about like a M2M connections, the pick and place machine and the capital equipment, and also our system too. But in the future, we believe that like SPIs should be connected to the AXI machine also to measure that like all of like a soda paste and also like a soda fillet, and then like a more volumetrics approach, not only that like inspecting. So we are our concept would be more measurement tools instead of like inspection machine equipment.
Right. Okay.
Yeah, actually, I'd like to add to that, Trevor, if I could, because that really is the core of what Koyoung technology is all about. We we came from the 3D world with our 3D SPI tool when we created our AOI tool. So we never had a 2D system. So we've been measurement based from the beginning. The approach is the same, and that's really what we see as a differentiator in the market. The information that you need to ensure that you're performing the best at the AI level, reduce false calls, prevention of escapes, auto-programming to a degree, because now we have to feed this information to an AI engine that can receive it and process it, is all based on really what we see as three things. It's getting the right kind of data, which is the measurement-based, parametric, quantitative, black-white information. Getting it the right way with the subsystems that are being used to ensure that it's accurate, repeatable. You have confidence in that information, which you now can use to make decisions on. Gathering enough of the 3D images to build the model. And then having enough of that data, the big data theory, if you will, right? Statistically relevant. Now I can feed that information to an AI engine for AOI programming. But even beyond that, it applies to the overall performance of the system at hand. So, right. Yeah, completely measurement based. You're absolutely right. That's and now we're offering things like critical distance measurement to go along with all the parametric information that we've been able to provide from day one.
Good, good. Richard.
Well, OMRON has always been a measurement-based, metrology-based solution. And when you factor in the fact that we have SPI, AOI, and X-ray, measurement really is key to tying the data all together on that. And that's something that we have done for quite a while. We continue to do, and we continue to build on it. Mm-hmm. So it's the very foundation of what it is that we have to offer, and we'll continue to build upon.
Yeah, I think it is pretty critical because I mean, obviously, your machines are the eyes and ears on the line, and you're putting all the instructions back to the stencil printers or the pick and place machines to make the adjustments. So it's got to be metrology based. Yes. Exactly.
As far as metrology goes, that's what 3D is.
Yeah.
The whole thing about 3D is we brought the inspection from being a comparator, high-level comparator, to now a true measurement tool. Mm-hmm. So we're measuring the length, width, height of all the devices. We're measuring for coplanarity plus or minus 1 micron. We're measuring the solder fillet. We're able to tell if we have a good fillet, the slope of the fillet, how much volume we have. There's only one way to get that, and that's through true measurement, and that's metrology. So quite frankly, all the machines, that's what they're all about is right. Metrology. So it's extremely important moving forward.
Right. Right. Okay, is there a demand for integrated test processes? I'm going to start with you because I know you've been doing some of it recently, where you're overlapping the AOI and SPI data with X-ray even. Do you think that's that's going to be essential going forward because you get to see where there's potentially a defect, but then you can look underneath the covers and literally see what's underneath the BGA, etc.
Exactly. Well, we all have a limitation. We all have a limitation when it comes to AOI. We can't see under a BGA. We're not Supermen. We can't see under the BGA. Right. So for that, you need X-ray. The goal is to provide all that information to a process engineer, and actually beyond that, to provide all that information to an AI engine that can do deep learning. Like we have what's called predictive neural synthesis. We collect all that information. From there, we develop golden process parameters for the entire process. That's going to be SPI, AOI, the whole manufacturing process, screen printer, pick and place, etc. So it's really key that we collect the inspection information from the SPI machine, post-placement AOI, post-reflow AOI, and of course X-ray, because we can't test under the BGA. Bottom line is we tell everything that's on the board. We can tell if it's all flat and level, all the solder joints look good, but we can't see if we're missing a ball or we have a component under a BGA. So it's really important and critical, I believe, to tie all the inspection process together. Otherwise, you're leaving that dangling participle there where you just don't know if you have good solder fillets under your BGAs or any device that's bottom terminated, quite frankly.
Right. Yeah, I mean, Richard, it's important, I think, that you gather all that information, and I know your systems don't do it directly, but that information needs to get back somehow to the designers, right, at the beginning of the process, and form rules-based judgments. What's your view on been able to use the different levels of inspection and combining test?
Well, I think you stated that very correctly, in that getting it back to the engineers is the critical aspect on this. And we do have the tools to go from SPI to pre-reflow, post-reflow, AOI, to the X-ray, AXI. We analyze that data. Specifically, what we're zeroing in on are anything that might be considered marginal.
Right.
Because that's kind of that, historically, that's been that gray area where challenges can come into place. And the tools that we have are designed specifically to minimize that marginality and continue to improve the process.
Right, right. Joel, you've got SPI and AOI. I don't think you've got X-ray, but I mean, how can you work with other partners to do that?
We do, and again, I think the goal here with everything that we're seeing over the last couple of years, and certainly this week with the Hermes and CFX initiative, is that we need to be able to communicate with all systems up and down the line. Test, X-ray, pick and place, and we've made a large investment, and there's a huge initiative in being able to sort through the mounds of data that we're collecting from our various tools. And because everything is 3D and very parametric, there's a lot more information to sort through to give actionable information to that engineer quickly, right? If not automatically.
Right.
So they aren't having to spend time looking and drilling down to find out exactly what needs to be changed right now to fix what's going on with what they're seeing. So having the connectivity, we've done, I think, a fantastic job with that with our K-Smart tools, and now even into the mount feedback world, where we can identify issues with spindles and nozzles and feeders on the mounters. So, yeah, information is the key. Data, right?
Yeah.
Data, lots of it.
Okay.
But how do you put it to work in a way that it can be utilized quickly or automatically, where somebody doesn't have to make a decision, right? It's taken care of through the AI approach.
Yeah. Okay. We're starting to run out of time, but I'm going to give the last word to Satoshi there. Coming back to the original question of comparing test sources, are you able to sort of compare either side by side or on top of each other your AOI results with your SPI and X-ray?
Yeah, actually, in the futures, like SPI and then the AXI machine, and of course AOI machines will be linked together, of course. And then this is like in the near future. But I think a lot of our AOI machines and manufacturers and SPI machine manufacturers and AXI tools have to approach about customers' loss cost, because of like all of our AOI, including us, has a possibility to escape something. Yeah. Because our operator also escaped it, and also the repair operator have a chance to escape, and our AOI also have a chance to escape. But by this kind of escape risk is on the customer side always. So we have to address about this, because of like a customer paying a lot of a penalty or fine to the end users. Mm-hmm. So we have to find a way. We have a plan to address this kind of loss cost, preventive approach to decrease a lot of loss costs from AOI or repairing process. Mm-hmm. This is I think in the future is happening.
Now, I think if you're using 3 sources, you've got much less chance of false calls and things like that, or escapes, should I say. But anyway, interesting debate, gentlemen. Because there's 4 of us, I'm afraid it's reduced in a time we could spend discussing this, but I'd like to thank you for taking part. Brian D'Amico from MIRTEC, Richard Osborne from OMRON, Joel Scutchfield from Koyoung, and of course Satoshi Otaki from SAKI Corporation. And thank you for joining us today.